Factor analysis is a statistical method that is used to analyze data extracted from questionnaire or survey. In this presentation, the factor analysis will be defined and described. Then the types of factor analysis will be mentioned, and then the assumptions required to be fulfilled before performing factor analysis will be listed, and finally there will be a section for interpreting an output for factor analysis. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, RStatistic, or Statistics, GraphPad, Prism, GPower, Python, and Mann. So what is factor analysis? Factor analysis is a data reduction statistical techniques. It is aimed mainly for data extracted from a survey or a questionnaire in which there are multiple items or questions, several questions, and the objective of performing factor analysis is to group these items or questions into groups or factors. So it is a statistical method that is designed to identify dimensions and factors, constructs, or sections in variables. Variables are the items or the questions. So the objective is to identify factors or constructs or groups and items that measures or measure that factor or constructs and load on that factors. So the factor analysis will examine and assess the correlation between those multiple variables, then identify groups of variables that are highly related so they can be assigned to a certain or specific factor or construct or a group. Then the questions will be grouped. Furthermore, the factor analysis will explain common underlying factor or factors or constructs. So the objective of factor analysis is to examine and assess and find if there is a relationship between items, then group them into factors or constructs, and then discover if there is an underlying structure, factor structure that represent or measured by those items. The factor analysis will uncover and generate a set of latent factors, and also it will assist in developing a theoretical model, identify any trends in data, and then determine the number of factors in a data, whether it is called factors or constructs or sections or dimension. It's all a group of items that hold together and measure factors. What are the types of factor analysis that can be used for in analyzing questionnaire or survey data. There are several types. The first one is the principal component analysis, which is abbreviated PCA. It is a reduction method, aims to reduce the number of items from a survey or a questionnaire or a scale or an instrument. It is designed that it will try to find a correlation between those items or questions and then group them into a component, and that's why it is called principal component analysis. The second type of factor analysis is exploratory factor analysis, abbreviated as EFA. The EFA can be called also principal factor analysis or principal axis factoring. The aim of performing that factor analysis is to explore the data, the items or the questions, and try to find if there is an underlying structure for these items by finding if there is a correlation and then group them into factors. So the objective of the EFA is exploratory, to identify common factors and unique factors. So it will aim to explore where there is a factors and the structure of the factors, the number of items or questions that can measure or represent that factor. The third type of factor analysis is a confirmatory factor analysis. Confirmatory factor analysis is performed post exploratory factor analysis. So the objective of factor analysis is to examine and identify if there is an underlying structures for the items, and then put and assort or assign the items to factors. The role of confirmatory factor analysis is to confirm or disconfirm the factor structure. So the CFA is the initial step for structural equation modeling. So what are the assumptions that have to be fulfilled before performing the factor analysis? The first assumption is the adequacy of sample size. The number of participants that filled or answered or gave responses for the items in a questionnaire have to be sufficient. Rule of thumb is that for each item there should be 10 participants or more. The second assumption is that there should be no outliers, no extreme values. The third assumption is that there should be a linear relationship among variables. The fourth assumption is multivariate normality, that the variables follow multivariate normal distribution. The fifth assumption that have to be fulfilled is there is no perfect multi-collinearity, which means that items associated or linked to each other with a high value. So there should be no high correlation between two or more independent variables. So the correlation between variables have to be not high, otherwise this could indicate multicollinearity. The sixth assumption is that the data has to be interval or ratio continuous data. However, the factor analysis can be applied for ordinal data. Ordinal data such as Likert scale, 5-point, 10-point Likert scale. The seventh assumption is the common variance, which states that the observed variables share common variance explained by the underlying factors. The eighth assumption is independence of factors. Factors are uncorrelated with each other. And the ninth assumption is that no rotation of the axis. Factors are unrotated at the initial analysis. The next slide is an screenshot taken from an SPSS software when performing factor analysis. As shown here, there are several methods that can be used for extraction in factor analysis: principal component analysis, principal axis factorings, image factorings, and other methods. On the right hand section, it shows that the method for extracting in factor analysis is the principal component. When the factor analysis is performed in SPSS, an output is generated and a table is generated for the correlation matrix. Correlation matrix shows the relationship between all pairs of variables. Here there are 8 questions, and this matrix shows the correlation between all the possible pairs of those items or questions. As shown here, item 1 with item 1, there is a perfect correlation. Item 1 with 2.6, the correlation value, which is the R value, is 0.66, and for 1 and 3 is 0.62, and 1 and 4 is 0.042. So there is a correlation between item 1 and 2. Between item 1 and 4 there is a weak correlation, and also a statistical significant value is given for each paired correlation. So for this output, the correlation coefficient R needs to be less than 0.8 and also need to be greater than minus 0.8. So the R value, the reasonable acceptable correlation coefficient between items, need to be less than 0.8 and greater than minus 0.8. And if the R coefficient is greater than 0.9, then delete one of the items or take the average for both items. If the R value is less than 0.3, then there is a weak correlation between the items, need to be deleted. If the R value is greater than minus 0.3, then delete the items as they show a weak correlation. In this output for correlation matrix, there is also an important value here, which is the determinant. It has to be greater than 0.401, and here from this table it is greater than that value. So these are the essential important observation and interpretation of the correlation matrix or matrix to consider when looking at correlation between items, the correlation coefficient, and the p-value and the determinant. Moving to the next slide. The next slide describes how to check the adequacy of sampling by performing a Kaiser-Meyer-Olkin measures of sample adequacy, as shown here in this small table, KMO and Bartlett test. The test shows that the value or the value that need to be acceptable has to be greater than 0.5, and ideally 0.8 will be the best value. So when performing factor analysis, to accept the method for analysis, certain assumptions have to be fulfilled. This is one of the assumptions to check for the sampling adequacy. The value should be greater than 0.5. And the Parlet test of sphericity is a test that will test whether the correlation matrix is in an identity matrix. The identity matrix is the matrix with all diagonal elements are 1 and all of the diagonal elements are 0. Then reject the null hypothesis if p value is less than 0.05. So we need to have the p value here less than 0.05 and this value to be greater than 0.5. So the output from the factor analysis shows the underlying construct for observed variable or variables, will identify common factors, factors that are common to multiple variables, and also will determine a unique factors. Unique factors are specific factors. Those are individual factor unique to each variable and not shared with other variable. Also, an output from the factor analysis shows the communalities values. So the communalities is the proportion of each variable variance explained by factors. A variable communality ranges from 0 to 1, and extraction values indicate the proportion of each variable or variable's variance explained by factors. So for item number 1 here, the communality is 0.86, the second one 0.5, the third one is 0.4. Anything less than 0.3 has to be removed from the analysis. The output for the FA analysis will also shows the factor loading. A factor loading is a measurement that indicates the strength and the direction of the relationship between variable and a factor. So high factor loading suggests a strong relationship. As shown here in the pattern matrix, there are here 1, 2, 3, 4, 5, 6, 7, 8 items have been grouped into 3 factors, factor 1 and 2 and 3. Factor 1 have 3 items load into it, or these 3 items, item number 1 and 2 and 3, measure for that factors. And as shown here, the loading value is 0.93, 0.7, 0.65 for the 3. So these 3 items hold together to represent or measure a factor. For factor 2, item 4, 6, and 5 hold together and load together to that factor. So it looks like they measure this factor. And finally, the factor 3 consists of item 8 and 7. They are loading into that factor with a value of 0.87 and 0.57. The right hand table is also a factor loading for rotated factor matrix, so which is part of the factor analysis. So one of these tables for principal component analysis, and the other one for exploratory factor analysis. So this output or representation that is generated by the factor analysis shows the loading for each variable or items to the specific factors. For the pattern matrix, you need to have a value or or a factor loading value greater than 0.3. Any value less than 0.3, then omit or delete that item from the analysis. Another value that is essential when pre-performing the FA analysis is the eigenvalues. These values represent the variance explained by each factors. The higher the eigenvalue, the more variance is explained by the corresponding factor. So here a table extracted from FA analysis for items in a questionnaire, and as shown here, there are 8 items and only 3 factors, factor 1 and 2 and 3. This table shows the total variance explained by the factors. And if we look at the initial eigenvalues, percentage of variance, we see that factor number 1 explain 27.6 of the variance, factor 2 25.7, factor 3 18.9. These 3 factors, they explain 72.36% of the variance. So these 8 items can be grouped into 3 factors, 1 to 3, and those 3 factors can explain or retain 72.3% of the variance. This is a section extracted from factor analysis in SPSS. This is a factor analysis for principal component. The scree plot is ticked, and the extraction based on eigenvalue set up to be greater than 1. In addition, also to look at the table of the total variance, a scree plot can be generated. A scree plot is used to visualize eigenvalues, identify point at which the curve level off, suggesting the optimal number of factors to retain. So this diagram shows on the x-axis is the factor number, and on the y-axis is the eigenvalue. The eigenvalue is set up at 1, and there are 8 items have been sorted into 3 factors: factor number 1, factor number 2, and factor number 3, and the cutoff point is 1. So there are 3 factors that can be generated when the eigenvalue is set up at greater than 1. There is also an important section when performing factor analysis is to choose the rotation method. As shown here, there are 2 major types of method for factor rotation. The first one is orthogonal rotation. Orthogonal rotation includes varimax, equimax, and quantimax. Those 3 types of rotation are used when there is no correlation between factors. The second type is oblique rotation that include promax and direct oplement. This type of rotation is used when there is a correlation between factors. So the method for rotation to select from are 5 different possible methods: varimax, equimax, quantimax, direct oplement, and promax. This can be done in SPSS. An output from the factor analysis will generate a factor scores. Once these factors are identified, rotated, and the items that load into these factors are identified, then factor loading scores is calculated for each items, and group of items that measure and load into the factor or the construct are also identified. So a group of items will measure the factor or the construct or load into the factorum construct. However, the FA analysis will only generate the number of factors or construct that can be obtained by performing the FA. Then the statistician has to give these factor a proper label or name that represent what these items are measuring. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.